NASA's James Webb Space Telescope last week showed us the most detailed images of the universe that mankind has ever seen. The out-of-this-world visuals from the JWST cameras were stunning, to say the least, and now the Space Telescope has sent new images that were taken in our solar system showing highly detailed images of the largest planet in our solar system, Jupiter, and its moons. The images that were released by NASA were from the earliest tests of the space mission's instruments. The images demonstrate that JWST can show space in clear detail, even of super bright objects close to the Earth, and can pick up more minor details. The images include images of Jupiter and images and spectra of several asteroids, which were captured to test the telescope's instruments before science operations officially began. We'll be talking more about these stunning images of Jupiter, so make sure you stay with us. Let's dive deep into the video. Fans of Jupiter will recognize some familiar features of our solar system's enormous planet in these images seen through Webb's infrared gaze. A view of the NIRC CAM instrument's short wavelength filter shows distinct bands that encircle the planet as well as the Great Red Spot, a storm big enough to swallow the Earth. The iconic spot appears white in this image because of the way Webb's infrared image was processed. Combined with the deep field images released the other day, these images of Jupiter demonstrate the full grasp of what Webb can observe from the faintest, most distant observable galaxies to planets in our own cosmic backyard that you can see with the naked eye from your actual backyard, said Brian Haller, a scientist at the Space Telescope Science Institute in Baltimore, who helped plan these observations. Webb, which launched on December 25, 2021, was designed to peer deep into the universe's past, studying the first stars and galaxies ever to form. But the Infrared Observatory is a highly capable multi-purpose tool, and astronomers will use it to investigate a variety of cosmic objects and phenomena, including some in our own solar system, as the Jupiter pictures show. With its 21-foot-wide mirror, the Webb telescope can pick out fine details of Jupiter and its large moons. The telescope's instruments gather light at infrared wavelengths, redder than visible light, which provides a different view than what the more than 30-year-old Hubble Space Telescope has provided. Clearly visible at the left is Europa, a moon with a probable ocean below its thick, icy crust, and the target of NASA's forthcoming Europa Clipper mission. What's more, Europa's shadow can be seen to the left of the Great Red Spot. Other visible moons in these images include Thebe and Metis. "I couldn't believe that we saw everything so clearly and how bright they were," said Stephanie Milam, Webb's deputy project scientist for planetary science based at NASA's Goddard Science Flight Center in Greenbelt, Maryland. "It's really exciting to think of the capability and opportunity that we have for observing these kinds of objects in our solar system." Make sure you stay with us right till the end because we'll be discussing some more interesting discoveries by NASA's Juno spacecraft later in this video. Scientists were especially eager to see these images because they are proof that Webb can observe the satellites and rings near bright solar system objects such as Jupiter, Saturn, and Mars. Scientists will use Webb to explore the tantalizing question of whether we can see plumes of material spewing out of moons like Europa and Saturn's moon Enceladus. Webb may be able to see the signatures of plumes depositing material on the surface of Europa. "I think that's just one of the coolest things that we'll be able to do with this telescope in the solar system," Milam said. "What's crazier is that James Webb captured this while moving across its field of view in 3 different observations. This basically means that the telescope is powerful enough to look for stars while being in the presence of a celestial body as bright as Jupiter. Additionally, Webb easily captured some of Jupiter's rings, which especially stand out in the NIRCam long wavelength filter image. That the rings showed up in one of Webb's first solar system images is absolutely astonishing and amazing," Milam said. The Jupiter images in the narrowband filters were designed to provide nice images of the entire disk of the planet, but the wealth of additional information about the very faint objects in those images with approximately 1-minute exposures was absolutely a very pleasant surprise. Webb also obtained these images of Jupiter and Europa moving across the telescope's field of view in 3 separate observations. This test demonstrated the ability of the observatory to find and track guide stars in the vicinity of bright Jupiter. But just how fast can an object move and still be tracked by Webb? This was an important question for scientists who study asteroids and comets. During commissioning, Webb used an asteroid called 6481 Tenzing, located in the asteroid belt between Mars and Jupiter, to start the moving target tracking speed limit tests. Webb was designed with the requirement to track objects that move as fast as Mars, which has a maximum speed of 30 milliarc seconds per second. During commissioning, the Webb team conducted observations of various asteroids, which all appeared as a dot because they were all small. The team proved that Webb will still get valuable data with all of the science instruments for objects moving up to 67 milliarc seconds per second, which is more than twice the expected baseline, similar to photographing a turtle crawling when you're standing a mile away. Jupiter is a whirling world in stunning footage from Juno spacecraft. Hang on tight as you watch this new footage of Jupiter. This sped-up view shows the perspective of NASA's Juno spacecraft as it flew just 2,050 miles above the gas giant's clouds on April 9, 2022. This was Juno's 41st flyby above the radiation-spewing planet, during which the spacecraft soared at a top speed of 131,000 miles per hour relative to Jupiter. That's more than 7 times faster than the speed of the International Space Station orbiting Earth, at about 5 times faster than the crew Apollo missions were traveling as they left Earth for the Moon. The colorful images were created from the JunoCam instrument's raw images, which officials upload to an image processing gallery that allows citizen scientists to add their insights to the raw data. While Juno's initial main target has been Jupiter, in January 2021, NASA authorized an extension of the mission's mandate to focus a little more closely on the planet's 4 large moons, especially Ganymede, Europa, and Io. Juno will run until September 2025, assuming it remains in good health. Radiation will likely be the mission's main threat as it attempts to continue its work for the next 3 years. But as long as Juno is active, it will serve as a scout for future missions at Jupiter, the largest planet in the solar system. And with that, we've reached the end of the video. Hope you enjoyed watching the video and knowing about the spectacular image of Jupiter being released by NASA's JWST. For more interesting videos, make sure you subscribe to our channel and also press that notification bell. See you at the next one.